Thank you very much. So I'm here to talk a little bit about how we think. We spend a lot of time at these conferences talking about specific systems and specific techniques, and often diving into, here is a specific exploit, here is a specific tool that I wrote. We don't actually talk very much about how we make our work scale and the patterns that we see and that we learn. And it's been my mission for the past few years to start trying to figure out how to talk to people about how to think. This is an defense offense agnostic talk for the most part, so should be relevant to everyone. So I'm going to start with some definitions that I find pretty useful because they make us think about what we do in different ways. So in my world, security is the set of activities that reduce the likelihood of a set of adversaries successfully frustrating the goals of a set of users. You'll note that nowhere in this definition does it mention a computer, because we are not actually here to do things with computers. They sort of tricked us when they named the field computer security. Actually, what we really care about is what happens to human beings. Security is just another property of systems. It's like performance, it's like reliability, it's like availability. It can only be evaluated in a context, in an operational context that is tied to humans, and from a given position within that system. It's a means to an end. None of us are important. We are janitors, and we would be much better served if we remembered it. What we care about is functionally efficacy. So when we talk about complex systems, we're talking about things that display emergent behavior. If you are familiar with the two schools of thought in complex systems, this is the Annapolis understanding, not the Santa Fe understanding. We don't actually have strange attractors and weird chaos math in that much of in that many of the systems at the level that we get involved with the defense. Socio-technical systems, this is a phrase that I hate because it is too long and not very useful, but these are systems which involve both human behavior and interactions with technical systems. All of our security problems are about socio-technical systems. Adversarial systems are complex systems where human actors have conflicts. This includes literally everything we do, also capitalism and war, which are why those are the two other places that we tend to draw analogies from, mostly incorrectly. So, this is kind of, the rest of this talk is me exploring the space that we think about these systems in and trying to come up with some distilled versions of things that I've learned over the past 15 years. Also, otters are cute and they help you wake up after lunch, so you're going to see a lot of otters. So when we talk about conflict, one of the things that we are always looking at is resource conflicts and the trade-offs that we can make, right? Absent luck, adversarial situations are always resource conflicts. Not all resources are interchangeable, though. If you have a terrain advantage and a secrecy advantage, you can't just swap those two things for each other, right? To draw on one of those aforementioned very ill-fitting military examples, a terrain advantage is high ground, right? If I have a position where I can overlook a valley, that's great, and that is not something that I can trade off for, having a network of spies in the region. It's not that those two don't both affect outcomes, it's that they're incommensurable, that you can't directly compare them for each other. Some resources, like a lot of the ones that we deal with a lot of the time, like money and engineer time, those can be traded off against each other in a lot of situations, not always. When we build systems, our goal is to make asymmetric problems for our adversary. When we attack systems, our goal is also to make asymmetric problems for our adversaries, right? The goal is to make them spend more money on defense than either they have available or then it makes sense for them to put in given the return on investment. And so then we win, or vice versa. We don't really understand the balance of resources in computer security. This is really fascinating, given that we sort of think of ourselves as engineers who understand our discipline. This is a slide from one of Kitty Masuris's recent talks, talking about vulnerability pools. And this is super early modeling work. It's really fascinating. Please go read the paper. But they're looking at what if you have a piece of software, are bugs a constant? How many bugs are likely to be rediscoverable? Can you, for instance, use bug bounties to effectively drain the pool of bugs that your adversaries have that you don't? The answer is it depends on the age of the piece of software. But again, this is groundbreaking research, and this is relatively new groundbreaking research. We don't actually understand the asymmetries in our field very well. So, any complex adversarial system that's run with real stakes is too complicated to fully understand. You cannot understand all of the interactions from silicon on die up through JavaScript running in a user's browser with kind of a full modern stack in between them. No one can. No team can. You can deep dive into specific bits of those. You can try and use, theorem proving tools, whatever, to be able to make statements about certain levels. But in the end, that kind of rigor isn't good enough, right? You need intuition. Intuition is how we guess, I think this is a problem at this layer. To get intuition, you need breadth, not depth. This is one of the things that disappoints me about the structure of the way a lot of folks go around, not early career, that's totally understandable, but kind of mid-career. I see a lot of folks diving into, I am going to become the best in the world at this incredibly narrow slice of things. And they don't get out and develop the breadth that they need to have intuition around defending real systems. It may be that depth is more useful as an attacker. While I'm trying to make this talk neutral, I don't really actually care about attackers, so I would love to see more people with more breadth. Intuition also isn't just about insight, it's about finesse, right? Guessing on the first round how hard you need to throw at a DDoS attack. Guessing, I think if we just make this small change here, we can at least disable this exploit for now. And that increases the cost of attacks, it increases, or sometimes lowers the cost of attacks, and it increases the speed of response, right? Intuition is a critical resource in your ability to actually apply security to real-world outcomes. In chapter 3 of Chuang Tzu, the kind of second text from Lao Tzu, a butcher is carving an ox for Duke Wenhu. And he tells the Duke, a good cook needs a knife once a year because he cuts, relatively cleanly. A common cook, he hacks, right? He'll go through a knife every month if he's butchering all the time. But if you learn finesse, if you learn how to go with the flow of a system and see those shapes, well, the Duke's butcher, he'd been using the same knife for 19 years because he just puts it where it flows naturally. He puts the knife where the bone isn't. If you only study inside your field, you are never going to learn. Steal ideas from anywhere else you can. Useful places I have found stuff, chemical engineering, aviation. There's a ton of stuff in aviation about systems reliability that, while it doesn't look at adversarial use cases, does look at reliable systems and tells you many of the things that you need to know about how to get people to do things under stress and why you want to accept variability there. Medicine's another one, right? There's a lot of stuff to be learned from a public health approach to security, looking at how do we actually get people to vaccinate their computers and children at the same time. Maybe not at the same time. Unfortunately, the only place where I've seen well-theorized adversariality is the military. I would love pointers to other resources. If you have non-military examples of adversarial theory that are worked out as theory as opposed to things that practice that you have to derive from, please come talk to me after. So I want to talk about the 4 kinds of flaws that you see in all systems. These are a bunch of disconnected episodes, so if you're just coming in, just jumping in the middle, it's fine. So there are basically 4 types of security bugs. There are math problems. If you have flawed primitives, right? If you have a bad lock, if you have a bad crypto algorithm, et cetera, There are those that involve people. We'll talk about that in a minute. There is negative asymmetry. This is basically you have built a DOS multiplier of some kind into your system, or you are victim to a DOS multiplier that someone else built because you decided to be on the internet for some dumb reason. And then there are those that shouldn't exist. How many people here have heard of the Church of Langsec? Pastor Manuel Lefroy presiding. How many people here have heard of a recent bug that involved an unexpected state transition? How many people here have looked at the libSSH CVEs since last night? Yeah. So humans should not write parsers. Humans should not write state machines. We are always bad at them. Humans should write state machine definitions and then let a computer figure out if you have managed all of the different possible transitions so that you don't end up like the libSSH team. Same thing with interface definition mismatches. This is another place where you get these kinds of errors all over the place. Make your protocols as simple as possible. Don't have protocols that require Turing-complete parsers. Don't use ASN1. Oh, whoops, too late. We built the world on it. Anyway, there are tools that can make the vulnerabilities that shouldn't exist not exist. This doesn't help if you've got legacy code like we all do, but so when I talk about problems involving people, this is what I do not mean, right? Problems involving people are not users being dumb. They are users having conflicting requirements and not understanding how the system that they're interacting with works at the detail which is necessary to do their job, and not understanding the implications of something that they're doing. One of my other big goals is for us to start thinking about users differently. There are three components to every system that you interact with. There is infrastructure, structure, and superstructure. Structure is the thing that the system nominally does, right? If you're looking at a banking system, this is the thing that manages flow of money in and out, transactions, all of this simple user-facing stuff. Infrastructure is the thing that we normally think about attacking. It's your DNS servers, your whatever. Superstructure is the political management and development framework, and that entire layer that sits above every real-world deployed system. Every one of these has a separate set of technical and social response structures. Every one of these has a different set of incentive structures for all of the actors who interact with the system. Do you understand what your adversary's incentive structures and cost structures are? I was really delighted to see another kind of black hat economics talk here yesterday, because I feel like in very few cases as defenders do we actually have any idea why people are attacking us. Like, we might know why, like, okay, they make some money, but how do they make this money? What are they actually making money from? What does their value chain look like? Are there weaknesses in that value chain? Do not forget the structure and the superstructure just because you mostly work at the infrastructure level. One of the worst bugs that I have ever dealt with, not worst in terms of technical impact, but most annoying for the customer, was a requirements bug where they didn't realize until very, very late that the tool that they were building had two fundamental properties: to prevent a piece of information from ever getting disclosed and to let people share that information. And when they realized that 6 weeks before production, they canceled a 90-man-year project because they just literally hadn't thought through it. So yeah, do not forget that you can attack and defend at those layers as well. Political motivations at the superstructure layer are a resource, right? If you are in a position where the only thing that your adversary has to offer the people working for them is money, and you have something other than money to offer the people working for you, that's great. You are going to get people that are more focused and more dedicated and care more, and you're going to get a very different kind of work out of them. We are very bad at understanding trust and truth. This is not something that we are aware of that we're very bad. How many people here know about Taylor Swift's secret InfoSec career? All right. Taylor Swift is also a security engineer. Just Google, you'll find lots of evidence. Anyway, we're very lazy about trust, right? How many here think that you can trust a CA? Okay. You're either scared or cynical. This is good. How do you get a list of CA keys when you install a new machine? How many people here have read Reflections on Trusting Trust? It's a great historical paper. You should absolutely read it. It's about all of the terrible things you can do with a compiler. We trust systems because, well, it's probably fine. It probably hasn't been owned. This motherboard has probably not been tampered with by the Chinese. I mean, maybe it has, maybe it hasn't. We don't know. Understand, and this isn't to say that you have to distrust everything and that you should always go down those rabbit holes. This is to say that you should be very clear about what you are and are not trusting, and what you are trusting despite knowing that you can't actually verify it, right? Don't let yourself be lazy just because everyone around you becomes lazy. Understand where your authoritative data sources are if they're under your control, and under what circumstances they're correct. How many people here have worked for an organization that had more than one canonical source of truth about user identity? Probably a lot of the rest of you did too, and you just didn't know about it because it was somewhere in some back room that actually like, oh yeah, there's LDAP and then there's Google SSO, and we trust both of them, sort of, kind of, maybe, but we don't actually know when we trust what. Know your single points of failure. It is better sometimes to have a single point of failure than to be confused about the nature of reality. You don't necessarily have to get rid of your spoffs. Sometimes you want all of your eggs in a single well-guarded basket, but you don't want to be surprised by the existence of that basket. Time is a fundamental resource in all adversarial systems, right? Latency of response is a resource for both you and the attacker. How many people here have heard of an OODA loop? Observe, orient, decide, act. So this is Colonel John Boyd, who fought in Korea, designed the F-16, or the set of maneuver warfare structures, or maneuverability warfare structures that led to the F-16. And basically, he realized that if you are in a dogfight and you have a pair of matched planes, what matters is the ability to react faster than your adversary, and in this case, turn inside your adversary, right? You've got this kind of circling, and if you can turn harder than the other guy, you win. So all else is never equal, but your response time makes a huge difference to the outcomes of an attack, whichever side you're on. This is what it means for security to be a process, right? Yes, it's also, okay, we can't just deploy software and throw it over the wall, but at the higher level, when you start talking about patch and response and continuing analysis and monitoring and all of these things, this is what you're talking about. When we see teams owning their own dog food, right, this increases response depth at the same velocity or increases response speed. When we talk about DevSecOps or whatever the buzzword is this week, right? This is what we actually want there. What we want there is to be able to turn inside the adversary. Unlike in physical conflicts, you get to choose terrain. When I say choosing terrain, I mean things like business plans, right? You don't normally think of the business plan of your company as a resource for the security team, but it absolutely can be, or it can be a nightmare for the security team, right? If you choose to take credit card payments on the internet and allow people to sell anything that they want on that site, then you have chosen to deal with a massive amount of fraud, drug trade, God knows what else. So you can make choices one way or another there, right? You can steer your adversaries, and it is useful to have someone on your security team who can go to, I don't know, business development, marketing, product strategy, whoever the people who are having that conversation, and say, hey, actually, we'd really like you to put some limitations in place on digital services, because the fact that we're turning into a DDoS market is making our lives really difficult, and it's going to affect the bottom line for the rest of the company. And you guys don't actually want that business anyway. So This is where you get to design the terrain for your adversaries. Same thing at the architectural level, right? You get to decide how much work somebody has to do to penetrate a system and which systems will fail together. Think about that conflict and think about that terrain seriously. Be wary of committing to terrain if you don't understand it yet, right? When the product team mentions to security that they're launching this big new product that has a very different business model, don't just say, okay, yeah, send the code over. Maybe actually talk to them and understand what's about to hit you. This goes back to breadth and depth. Yes, you need to focus into the task at hand, but you also need to understand its context. We're really bad at doing this. We like focusing on narrow tasks. You need to visualize that larger space that you're working in. This is especially true, as you get more experience, this becomes more intuitive for you. If you have a less experienced security team, you need scaffolding to help them. You need scaffolding to help them with whoever it is. This is a constant need. Some of us are better at recognizing it. Draw pictures, whatever it is. Share the picture, literally, physically, print it out, put it on everybody's desk, whatever you need. But then enable decisions that take the context into account at the edge, right? Where people are actually making discrete technical choices. Make sure that those people have the context and then let them do their job. Let them go back and forth. So principles. We've got our lecturing Professor Ott here. He has a tweed jacket somewhere. You need tools to think with, right? These are some of the tools that we tend to use for thinking about systems and designing systems. There are a lot of other tools out there. There are a lot of other principles in which you can design a system in mind, and focusing relatively narrowly on a small set of principles is not necessarily useful. It can be much more useful to evaluate the set of principles that your problem has. Here's a short-ish list of principles that I've seen in the context of, among other things, trolling through a ton of DoD publications. But there are a lot of things that you can use to kind of engineer and think about the way you think about things. So, even if we ignore all of the kind of corporate espionage, deep state, woo land, your adversaries are watching your actions, right? They're going to do things that tell you what they're going to do, and you should be watching their actions, right? You don't have to necessarily, especially if you're in a bigger system, wait for attacks to just come in. We have honeypots. Among other things, honeypots are a way of dragging in adversaries and helping to explore how they're going to act over time. Don't just look at honeypots for vulns. Look at honeypots for the structure of attacker actions. Try and get to know them. Try and get to know what they're doing. Try and get to know how they think. Consider your own level of sophistication, whether or not this is something that, you probably have lower hanging fruit there first. But at some point, you should think about that. If you're an attacker, remember that you have your own infrastructure. Don't forget to patch your infrastructure just because you're on offense. Don't write bad code because you think you don't have to defend it. Defenders, remember that they're totally going to forget that, and that you can absolutely go after their infrastructure modulo certain legal complexities. So stuff breaks, right? You just kind of wall up your own side sometimes, whatever. Stuff will break. What happens then? Adaptive capacity is how you recover, right? This is not a property of technical systems. This is a property of human systems. It means slack in your team, right? This is a thick property in kind of anthropological terms. It's not something that it's easy to measure, but it's something that you need to spend time with those teams and figure out, how stressed are they, how tight are deadlines, all of these kinds of things. It means rich relationships across groups, right? If you have a siloed security team and then a bunch of ops folks and they never talk to each other except when something breaks, it's going to break badly when it breaks because they're not used to working together. This means smart people who've had vacations. Take vacations. I shouldn't have to tell Europeans that. If you're an American, take a fucking vacation. Do not automate things. Orchestrate them. For example, let's say you have an HR system that you want to make sure that you burn an employee who's leaving out of all of the accounts because you got burned once because some critical production account, somebody didn't get locked out and they were really pissed off, right? Great. You've automated this thing. Now HR clicks the wrong button and your CTO just got burned out of everything with no recourse. Yes, this does happen. Yes, it was very expensive. If you orchestrate that, you keep a human in the loop, right? And it can literally be somebody on the IT side who clicks the button that then kicks everything off. But at least there's a human who receives the request and say, wait, did the CTO actually quit today? That seems weird. Let me call somebody. So the joke used to be, and this is probably a joke that many of you in the room are too young for. Lisp programmers, it said, know the value of everything and the cost of nothing. Okay, there's one Lisp user here. Engineers in a modern environment, especially if you're in a cloud environment, have the opposite problem, right? They know how much everything that they interact with costs, right? Because you get this nice little itemized bill. But they don't necessarily know, like, oh, is this the right amount of X? Is this whatever? For instance, let's say you have the really critical database that only one small team in customer service has to get access to, and it's where all the PII lives, right? And you have, you're a commercial bank, you have a very low transaction rate, right? You do maybe a couple hundred transactions a day, and you do maybe a couple hundred customer service, requests a day. Why do you have a database that can do 1,000 transactions a second sitting on all of that PII? You don't need that capacity. Now, as an attacker, what that capacity says to me is, sweet, I can use that. You've given me a weapon. You have given me a data exfiltration weapon that I can now use against you, that there's no reason for it to exist. A side benefit, let's say you know that your 98% percentile transaction velocity is, 1,000 transactions an hour. If you put a hard cap at 1,000 transactions an hour and somebody starts trying to exfiltrate from that database, and there's a lot of ways you can do that hard cap, crypto, lots of fun toys, then your customer service people are going to be like, yo, the database is really slow today. What's going on? Are you doing maintenance? And when you get that call, the first thing you're going to do is look at, like, okay, let's look at the transaction rate and what job went out of control. And you see that, no, there isn't a registered job that went out of control. Congratulations, you've now turned your customer service team into a sensor by making their job harder. Not actually very harder. It's only harder in the cases, assuming you did your math right, it's only harder in the cases where you really want them to get in touch with you. For Tor, the Tor project has been playing a game in China for a long time around the visibility of their systems versus the Chinese state. So at one point, and this was a while ago, they had a list of 42 tells, places where they knew that Tor traffic varied from traditional TLS traffic. So instead of just, oh, well, we should just look like traditional TLS traffic, they took them out one by one. Because they knew that each time they took a tell out, they would get somewhere between 1 and 6 weeks of functional operation in the field. So why would they burn all of that at once when they can just play this game? Excess capacity is a resource. So let's talk about measuring things. You cannot measure risk. Lots of people like to measure risk. They like to pretend that they understand the probability in which Igor will wake up, be pissed off at them, and decide to launch a DDoS attack. If you know Igor, great, cool. You can just check in with his buddies and be like, how's he doing today? Do we need to call the CDN? You don't. Unless you are seeing a significant percentage of the internet traffic, which means you're one of 5 companies, you cannot define probabilities for technical attacks. You can define them for fraud if you're a merchant, etc. Measure things that you can measure. Don't lie to yourself that you can measure things that you can't measure. Has anyone here read the book Seeing Like a State? No. Okay. Seeing Like a State is talking about how if you are someone who has authority over an emergent system and you start measuring a certain part of that system and taking action on those measurements, you will distort the system and the measurement. This is true for states, this is true for ISPs, this is true for companies doing defensive security. Anytime you measure and act on that, if you are an empowered enough actor, you will ruin your measurement. Please learn qualitative measure methods. This isn't quite a way out of the first trap, although it will help evaluate your own measurements. We as engineers have an obsession with quantitative measurements, with quantitative metrics. It is not a very useful obsession in many, many cases. We would build better systems if we understood qualitative tools. Finally, last one. Assume failure, right? Over a long enough time, everything breaks. The likelihood of system compromise always goes to 100%. All data is eventually deleted or public. So how have you designed for compromise in the systems that you've built? Right? This is not something that you can ignore in the requirements of your system. Oh, what do we do when this database gets breached? Just literally design for it from the start. It will make your life much less annoying. So notion of exposure tolerance, basically how much exposure an organization is willing to put themselves in for a given return. Make sure that everyone in your organization has a shared exposure tolerance, or they will get you in trouble. Here's a quick review of these 14 lessons, and I'll put the slides up later if you want. Any questions?
Microphone.
By the way, if you're interested in any of this stuff, I do strategy and architecture consulting. Feel free to get in touch if you have complicated problems in the 40 to 400 engineer range.
Hey, thanks for the great presentation. You mentioned that we shouldn't really pretend to measure risks, but that kind of destroys a very important part of security planning in companies. So what should we use instead of measured risks to actually plan for security controls and stuff like that?
I talk about exposure and about cost ratios, right? You can talk about what is the cost of occurrence, what is the cost to mitigate beforehand, what is the difficulty and or cost to an attacker, and what is the return on investment to the attacker, right? The thing that differentiates exposure from risk is normally when you want risk, you put a probability factor in there that's the likelihood of the attacker launching the attack. All of the other things in there, you can actually model and or research reasonably. That probability factor is 99% of the time utter bullshit. And you don't need it. Like the thing is to do the decision support that is required to adequately model the, the kind of security decisions and trade-offs that you're making. You don't actually need that number. So just use exposure. It works well enough. And you're not lying to yourself.
Sorry. But I think it's really important because many times you will have a very valid risk with all the other properties. And then when your boss might ask you how probable this risk is, you have to answer, yes.
Then you need to have a conversation with your boss about not being able to, honestly, most of the time what that's looking at is, oh, this would be very bad, but it's an incredibly difficult attack to launch.
Yeah.
Right? This would be very bad, or the return on investment is so small that it's incredibly unlikely that anybody is ever going to bother renting all of AWS for a weekend to attack us. You don't actually need that risk number. If your boss insists on a risk number, you need to have a conversation with him about data fraud and whether or not, whether he wants to be lied to, because he's asking you to lie to him. And it's very important if he's the recipient of that data, he needs to understand why this isn't valid data and why adversarial risk or adversarial exposure isn't like things where we have actuarial tables for. Because if he doesn't get that, he's not going to be making good decisions with the data you're giving him. So I would say if your boss is insisting on that, it is literally your duty as an employee to educate him about why he doesn't want the thing that he asks for.
To the same point, but what if the discussion changes from security to safety?
So,
for instance, public infrastructure or
right?
something like that.
So even if The question is, do you have meaningful data about probability, right? If you have meaningful data about probability, if you don't know whether it's meaningful or not, ask an actual statistician. If you have meaningful data about probability, by all means use it. You just mostly don't. And what I'm not saying that you shouldn't use data that's real. I'm saying that you shouldn't lie to yourself, because that will just get you caught out.
So it's more about the definition of actual risk than probability is probably a word that should be used for risk in many cases. Like a probability of an attack equals the risk I have.
No, the probability of an attack being launched, right?
Yes.
You do not have a model for attacker behavior.
Yes.
Unless you are doing merchant fraud or a few fairly small categories. Don't make up data. Because most of the time we make up a probability value for how likely is somebody to launch this attack.
No, my question was more pointing at, I work in railway, and so we build trains. So
yeah.
I have a train that runs certain IT systems, and some systems require internet access. Mm-hmm. So now I have this fleet of, 1,000 trains or something that's rolling around and is trying to keep people alive. So I cannot measure the risk of somebody attacking my train.
Yes.
So how do I reasonably define security measures, or do I just say it's human lives, do as much as you can?
So what you do is you look at the cost metric, right? There's a cost of that attack occurring, right? You have actuarial data for the cost of a human life. Okay, that stacks up here. Here's how much the engineering work to fix this bug is. Here's how much it costs the attacker to launch the attack. Here's, our understanding of like, oh, okay, this is a terrorist organization, so, we've assigned them some ROI, whatever, right? Just cost ratios. Cost ratios do the thing that you need to do there specifically, and they don't end up muddy. For instance, you have a bunch of other stuff like bridge failures or track failures, whatever. You have data there, right? Don't muddy those two by making up data so it matches the form in places that you don't have. And I would hope this, I may be very disappointed, but I would hope that the folks who are doing risk evaluation work for something like a railroad are willing to have that conversation around data quality. And are willing to at least have a conversation that, like, look, adversarial situations have a different set of metrics than non-adversarial situations, and there are places where we don't have good metrics there.
Kind of the part of the problem is this is mostly infrastructure, and all attacks or scenarios involve nation states mostly all of the time.
Yeah. And I mean, if your national intelligence organization is willing to share probability data with you, great. By all means, use risk. They're probably not. So
yes.
Yeah.
Thanks. We'll take one more question. I'm sure Ella will be around outside and be prepared to have more discussions.
Yeah, thanks for your talk, Andreas. I was wondering one thing. You were mentioning that defending complex systems requires intuition and some kind of finesse, if I understood that correctly. So my intuition told me in exactly that moment, how do I transfer my potential intuition based on experience to someone who's not as experienced like myself? So how do I basically get intuition scale, in the border people?
That's a question with a very long answer. I think the biggest answer is that we don't know, and that apprenticeship is basically our best bet. And I would argue that the way that you want to design the apprenticeships is to encourage like a few specific deep dives so that you understand the full scope of a couple of problems, and then as much breadth as possible. And that seems to be the best bet, but we don't. It is a problem that we are now in theory 20 or 30-year-old profession, and we have no idea how to train people. We should figure that out maybe. Thank you very much.
Okay, thanks, Ella.